So section 1.2 is called rates of change. So there's one main idea in this lesson, and it's basically finding what's called average rate of change. So you guys will learn how to compare the rates of change of 2 points using the average rates of change, and then how to describe how two quantities vary together at different points and over different intervals of a function. So we're going to look at it from a graph. We're going to look at it from a table. We're going to look at it from our calculator standpoint, okay? And you guys are actually learn how to do some calculus in this lesson, even though you guys don't know it's calculus yet. It's pretty cool. Okay. So average rate of change. Hi. Okay. When you guys hear rate of change, what does that sound like? That you guys already know about? If you guys don't know, it's okay. The slope. Okay, so up till this point in your mathematical journeys, you guys have only been able to find slope of a line, rise over run, right? We actually can find rate of change of any function. Okay, they're in the basket. Okay, so average rate of change, it doesn't matter if it's a line, quadratic, something crazy, trig that you guys will learn later, okay? But average rate of change formula is the change in the output values, output values, divided by the change in the input values. Now, one way that you guys will see this written is like this. That's not a triangle, even though it looks like a triangle. This is a Greek letter. Do you guys know what Greek letter this is? Delta. Delta y over delta x. Delta in Greek in mathematics means change. So it's the change in y over the change in x, which is the same thing as, this should look familiar to all you guys, y2 minus y1 all over x2 minus x1, which is the formula for what, guys? Someone already said it in here. The slope, right? This is the slope formula, so I'm going to write it in red. Don't gaslight me, guys. You guys know that, right? Okay. Whew. You guys scared me. The slope. All these things mean the same thing. Change in y over the change in x. Change in outputs divided by the change of the inputs. Remember, y is going top. Okay. So the first example we're going to do is you guys have this graph, and then there's a little blurb underneath it. Go ahead and tape everything in together. Okay, so this one's actually really nice because do you guys see how it gives you guys 2 points? Okay, so they actually did the hard part for you. A lot of times what you're gonna have to do is actually figure out what the y value is by plugging it in. And because you guys are AP, do you guys see how there's fractions in this equation? They're gonna expect you guys to be able to do this by hand. So if I plug in 1, I'd have to do order of operations to figure out what it would be. But guess what? If I plug in 1, what does it give me? 2. If I plug in 3, I get 4. And I actually checked it to make sure, because I steal these problems from other people. I checked it, and yes, those are the points. Okay, so what I want us to do is, the best we can, here's a graph. What I want you guys to do is plot that point on this graph, plot this point on this graph. So the point 1, 2, is somewhere, looks like right here. And then the point 3, 4 looks like it's somewhere about right here. Okay, now what type of function is this? It's U-shaped, quadratic, okay? So that's not linear, obviously, right? Linear is lines, but since we're finding a rate of change, don't you guys agree we're finding slope? So what I want you guys to do is I want you guys to use a ruler and draw a line between those 2 points. Because what we're actually doing here is we're trying to find the slope between these 2 lines. And this wasn't explained to me when I took calculus. I was so lost at the beginning. It just, everything was happening so fast. And so I want you guys to understand this so that when you guys do go to calculus, you guys will learn something called average rate of change, and then you guys will learn what's called the instantaneous rate of change. Those are 2 different things. And graphically they look different, and then the math steps you guys do are a little bit different, okay? All right, we know how to find slope between 2 points by now, right? So this is gonna be x1, y1. This is gonna be x2, y2. So remember, slope is the same thing as y2 minus y1 all over x2 minus x1. So talk to me, guys. What am I gonna write on top? 4 minus 2. What goes on the bottom? 3 minus 1. So let's do some quick mental math. 4 minus 2 gives me 2. 3 minus 1 gives me 2. What's 2 divided by 2? 1. So what's the average rate of change between these 2 points? 1. Does it look like it's 1? Kinda. Maybe. But we just for sure figured out that it's 1. Okay. So what's interesting about this is, do you guys see how the steepness is, that's the slope, right? That's the rise, that's the run. Do you guys see what I'm saying? However, if I were to pick a different point right here and calculate the slope, do you guys see how that line doesn't look the same as this line? So if I picked a point that's closer to this point, the slope's gonna change. That's why it's called an average, because parabolas are different. Do you guys agree that it curves? As you get closer to this point, do you guys agree the slope's gonna change? That's what calculus helps us figure out, is the change as you get closer and closer and closer and closer and closer. Okay? Cool? All right. So instead of a graph, what if we have a table? If you want to calculate the average rate of change, be careful that the output values are always in the numerator. What are outputs? X's or Y's? The Y's. Questions so far? Are we okay? Did I weird you guys out with my little speech? A little bit? Sorry. I get excited about this. It's cool. All right. At least you guys can't say I'm boring, right? So, all right. What is the average rate of change on the interval from 13 to 25 seconds? Okay, so we need to read the problem correctly. 13 to 25 seconds. So which row is that? Top row or bottom row? Which row says seconds? Top row. So what I'm looking for is, what is the change from 13 to 25 seconds? Now, if I'm looking at these two numbers, I want you guys to think about these as ordered pairs. This means 13 comma 76. Does that make sense? And 25 comma 30. So this is going to be my x1, y1. This is going to be my x2, y2. It's the exact same idea. It's just a different problem. It's a table versus a graph. Okay. So I'm looking at this change and this change. Okay. So I'm going to write this down. 13 comma 76 and then 25 comma 30. So this is going to be my x1, y1. This is going to be my x2, y2. And we're just going to calculate the slope again. So m is equal to y2 minus y1 over x2 minus x1. So it's going to be 30 minus 76 all over 25 minus 13. Now, for this type of problem, because it's a real world context, they're probably going to want a decimal versus a fraction. So I know I've taught you guys to do alpha x, right? To do this without doing that, all you're going to do is parentheses 30 minus 76 divided by, what's on the bottom? 25 minus 13? Okay, 25 minus 13. So do you guys see how I grouped them in parentheses? This would be the top. You want all of that divided by the bottom. And what do we get, guys? Negative 3.833. Okay. Okay. How many decimal places did I say to round to in this class? 3. Good. So negative 3.833. You guys cool with that? So I'm going to say this is equal to negative 3.833. Now, I know in Math 3, I told you guys to do the little approximation symbols, and AP, they don't care. If you guys just put equals, they're not going to ding you guys for putting this versus approximate squiggles, okay? Cool. This looks ugly, so I'm going to rewrite it. Now, here comes a really important part. This is a real world context, right? Whenever you guys do average rate of change, and that's where this part comes in, it's always something per something. The y values always go on top. So the y values are measured here in meters, right? And the x values are measured in terms of seconds. So this is negative 3.833. We're going to say meters per second. Okay? So if ever on a test, quiz, whatever, AP stuff, if it says to include units, you have to put that, okay? Meters per second. Is anybody taking physics in here? You are? Anybody else taking physics right now? How is it? I'll cover up the speaker. It's good? Okay. I was traumatized. I don't think I told you guys this. I was traumatized by my physics class, and so eventually one day I would like to retake it again because it was really bad. My professor, it's not good. You know, like in math, we give you guys partial credit on stuff. If you made one mistake, you should just put a big X through it and give you a 0. Okay? We had an exam where we had 4 questions worth 100 points. Each question was 25 points. So let's do some math. If you got a 0 on one of our questions, what's the best score you could get? What's 100 minus 25? 75. So if you miss one question, the best grade you could have got is a C on our test. So I took my first exam, guys. I was so excited. This is being recorded now. And I walked out of there all confident. When I got my score back, it was not good. But luckily, the rest of the class did really bad and she let me retake it and I got a B. But it was hard. All right. So in our class, the word per is a key indicator that you're dealing with a rate of change. Miles per gallon, students per classroom, online gamers per server. This also tells you which variable is dependent or independent because, highlight this, the dependent variable is always listed first. That's the y values. This example is, I don't want to rush this example because this is really important. So let's do this. Just tape this in, guys. I know a couple of you guys are done with your homework, but the rest of you guys, do you guys want to start checking your answers while you guys are still here? And then if you guys need help on any of them, let me know before you guys go. But this is where we'll start on Friday.